Hello everyone. Today I am here to present a seminar on fundamental topic in chemistry, atoms and molecules. So today we will be learning about the concepts of atoms and molecules, to learn about symbols, atomic mass, molecular mass and symbolic representations, to understand Avogadro's hypothesis and its importance, to perform basic calculations involving moles concept, to clarify the relation between vapor density and relative molecular mass. So introduction. So what is an atom? Atom is the smallest unit of an element that retains its chemical identity. It contains protons, neutrons and electrons. For example, hydrogen H, oxygen O, sodium Na, chlorine Cl, etc. Next we learn molecule. Molecule is a combination of two or more atoms chemically bonded together. Examples: O2, H2, etc. Molecules are made up of atoms in a fixed ratio. If the molecules have same kind of atoms, they are called homoatomic molecule. For example, two molecules of oxygen, two molecules of hydrogen, etc. Then, if the molecule have different kinds of atoms, they are called heteroatomic molecules. For example, H2O, NaCl, etc., which all says our compound. The number of atoms present in the molecule is called atomicity. Next is Dalton's atomic theory. This modern atomic theory is formulated by John Dalton. The main postulates of this theory are: one is all matter is made up of atoms. Then the atoms of the same elements can have different atomic masses. They are called isotopes. Next, atoms of different elements can have the same atomic masses. They are called isoquants. Atoms do not combine in small whole number issues. The atoms can be transformed into atoms of other element. Then atom is the smallest particle that takes place in a chemical reaction. Mass of an atom can be converted into energy. Next is atomic mass and molecular mass. Atomic mass is the mass of an atom. It is the sum of number of protons and neutrons in an atom. So it can be expressed in AMU. This is atomic mass unit. Molecular mass. Molecular mass is the sum of atomic masses of all atoms in a molecule. So for example, molecular mass of water is H2O for H2O, that is two molecules of hydrogen into 1 gram of hydrogen. This is similar with 1 molecule of oxygen into 16 grams of oxygen. So totally we have 18 AMU. Next we have mole concept. What is a mole? Mole is a unit that is used to count for small particles like atoms, molecules or ions. 1 mole of an element is equal to 6.022 into 10 raised to 23 particles. This number is called Avogadro number. This name is named after an Italian scientist, Amedeo Avogadro. The number of moles can be calculated by different ways. from the number of molecules, from the number of atoms, from the volume of a gas at its STP. STP is nothing but standard temperature and pressure. That is 1 mole is equal to 22.4 liter. Then finally from the number of ions. Next is molar volume. Molar volume is nothing but the volume occupied by 1 mole of a gas at STP, that is standard temperature and pressure. So 1 mole of any gas is approximately equal to 22.4 liter. Then molar mass. Molar mass is the mass of 1 mole of a substance. It is expressed in gram per mole, that is G by mol. So these definitions are very important. So this is the diagram representing the relation between the mole, molar mass, molar volume and the so here is the diagrammatic representation to show the relationship between the moles to the molar mass, gas and liquid. Next is percentage composition. Percentage composition shows the mass percentage of each element in a compound. For example, we take a percentage of hydrogen and oxygen in a water molecule. So how to find this? We already know that molecular mass of H2O is 2 into 1 plus 16, which is equal to 18 grams. So molecular mass of H2O is 18 grams. So for finding the mass percentage of each element, we have a general formula like mass percent of an element equal to mass of that element in the compound divided by molecular mass of the compound into 100. So hence using this formula we get mass percentage of hydrogen is 11% and mass percentage of oxygen is 89%. So in this way we can find the percentage composition of an element. Next is Avogadro's hypothesis. Avogadro's law states that equal volume of all gases under the similar conditions of temperature and pressure contain equal number of molecules. That is, equal volume of all gases under same temperature and pressure will have equal volume of equal number of molecules. So we have a formula for this. If V is the volume and N is the number of molecules of a gas, so according to Avogadro's law, V is proportional to N. Next we have relationship between vapor density and relative molecular mass. Relative molecular mass is nothing but it is the ratio of 1 mole of a gas to the mass of 1 atom of hydrogen. Okay, so relative mass, we have short form of relative molecular mass is RMM. Next is vapor density. Vapor density is the ratio of the mass of a certain volume of gas to the mass of an equal volume of hydrogen, which is at same temperature and pressure. So now relation between vapor density and relative molecular mass is relative molecular mass is equal to twice its vapor density. So here in the formula we see RMM equal to 2 into vapor density. So why is this? This is because hydrogen is a diatomic molecule. So now we can see many problems to solve. Okay, so first we have to find the gram molecular mass of H2O. So for that we need to know the atomic masses of hydrogen and oxygen. So with these numbers, first we have to find gram molecular mass of H2. So for that we can write it is equal to 1 into 2 plus 60 into 1. Finally we will get the answer 18 grams. So gram molecular mass of H2O is 18 grams. Now second question, calculate the number of moles in 46 grams of sodium. So for that we have a formula, number of moles is equal to mass of the element divided by atomic mass of the element, which is equal to 2 moles of sodium. Now third question, calculate the mass of 0.3 mole of aluminium. Yeah, so now we have, so they have given the atomic mass of aluminium is 27. So with that we have to find the mass of 0.3 mole of aluminium. So for that we have a formula, number of moles is equal to mass of aluminium divided by atomic mass of aluminium. So in order we have to find the mass, so mass is equal to number of moles into atomic mass. So mass of aluminium is equal to 8.1 gram. Fourth question, calculate the number of molecules in 11.2 liter of carbon dioxide at STP. So number of moles of carbon dioxide equal to volume at STP by molar volume, which is equal to 0.5 mole. Then number of molecules of carbon dioxide is equal to number of moles of carbon dioxide into Avogadro's number. So that equal to 0.5 into 6.023 into 10 raised to 23, which is equal to final answer 3.011 into 10 raised to 23 molecules of carbon dioxide. So this is the answer. So similarly we have many problems. It is available in the textbook. So finally we will recap what and all we have learned in this topic. Yeah. So first is the atomic mass is the sum of number of protons and neutrons of an atom. Then molecular mass is the sum of atomic masses. Then Avogadro's law. So what is the Avogadro's law? According to Avogadro's law, equal volumes of all gases at same temperature and pressure can have same number of molecules. Okay, and we have Avogadro's number 6.022 into 10 raised to 23 particles. Then molar volume, it is the volume occupied by 1 mole of gas at STP. Then molar mass is mass of 1 mole of a substance. Then vapor density is the mass of certain volume of gas compared to the mass of same volume of hydrogen under the same condition. Finally, relationship between molecular mass and vapor density, that we have RMM, that is molecular mass is equal to twice the vapor density. So we have an assessment. So these are some of the questions. So you can all have a practice at home. Find out the answers for these questions and bring it on the next class. Thank you everyone. Hope you all enjoyed the session. Thank you.